One very important parameter in gear terminology is the pressure angle. Let us see together what do we mean by pressure angle. You know that gears in contact will transfer a force between them, and this force will be normal to contact, okay? And the contact in general will take place through teeth. So if I consider the following involute teeth, okay, then we have seen together that I can have at any instant at least a point of contact on the pitch circle. And we said that along this, from this contact point, I can determine the pitch radius. Okay, the circular pitch radius. So as you can see here, we have, this is our involute, and we have the normal to it will be the line across which we have the contact, the normal to contact between two teeth. So the force transmitted will be along this line, and this force transmitted will be perpendicular to the tangent line to the involute. Okay, so we'll see together in next slide a clearer figure where it's shown how the two teeth are in contact, and then we can define the tangent line to contact, the normal line to contact, and we can say that the pressure angle will represent the angle between the line of force transmission. So this is your force. Your force will be transmitted between your gears along this line. So you have a force normal to contact, perpendicular to tangent between the two involutes that will be in contact with each other. Now, we said that this contact point, if you remember, will lie on your pitch circles, okay? And this will allow you to define what is the pitch radius for each of your two gears. And the radial line will go from the center. So the radial line will join the centers of your gears. So here you have a line passing by this point and the center of your gear from this side. So this is a radial line. And we can say that in this case, we can define the pressure angle as the angle between the radial line passing by the center of this gear and the contact point on the pitch circle and the tangent to the involute. So this is what we call the pressure angle. Okay, so the force will not be the force will be divided into two components if you want, one tangential to your gear and one normal. Of course, we know that the component that will lead to rotation is the tangential one. So now this force will decompose it into two parts, one along the tangent direction to the circle, and this will cause the rotation of your gear. And another component is the normal one. The normal one will not do any useful work, so it will it will contribute to mechanical constraints. This is why in general we try to have alpha not very large, okay, to transmit enough power, because the useful component is F cosine alpha, okay, or alpha prime here. The name is alpha prime here. You have that alpha prime here is equal to alpha. So you can define the pressure angle here in two ways. You can consider it as the angle between the tangent to your pitch circle and the normal to contact between the teeth, or you can say also it's equal to the angle, this is equal to alpha prime, between the radial line and the tangent line to the to our involute. Okay, why it's the same angle? Because you know that the radial line and the tangent to the circle, to the pitch circle, is the angle between them is 90 degrees. And also the angle between the normal to the profile and the tangent to the profile also is 90. And you know that if we have two lines doing an angle alpha between them, if we draw the perpendicular to the first and the perpendicular to the second, okay, the angle between the two new lines will be the same. This is why this angle here is equal to this one, because these two lines are perpendicular here, and these two lines, the two other lines, are also perpendicular. So this angle will be equal to this one, okay? So the pressure angle exists between the tooth profile and a radial line to its pitch point. In involute teeth, it's defined as the angle formed by the radial line and the line tangent to the profile at the pitch point. Any question on this? Now, here you can see it in a clearer way. You have here two gears in contact, okay? And this is your teeth that are in contact with each other. You have, as we defined before, a contact point on the pitch circles of both gears. So this is the contact point. You can draw at this contact point a tangent line to contact and a normal line. Your force, your transmitted force, so the force here from A on B will be up, okay? So this is F of A on B. And by action reaction, you have the force of B on A, which is downward. So this is F of B on A. So due to this interaction, this force will produce for gear 1 a rotation into the counterclockwise direction using the right hand rule, and the component, the useful component, is the one along the tangent line to the pitch circles. Okay, so I just have to project by multiplying by the pressure angle. So we do FAB cosine alpha. This will give us the projected force. We multiply it by the radius, by the pitch radius of our gear 1. We get the torque that is involved, and then this will lead to a rotation of our gear. Okay, and you have from the other side for gear B, sorry, for gear, one second, yes. Here we were considering the rotation of this one. For the other gear, the force of this force, okay? So here you have the action of A on B is up. This will lead to a rotation in this direction, okay, in the counterclockwise direction. However, if we consider the lower one, we have seen already that for external gears, okay, they always have opposite angular velocities, okay? Now, in general, when you have a driven gear and one that is driving, for the driving gear, we put a couple. And for the driving gear, we put, for gear A here, we put a couple that will rotate it. So we have a motor to drive gear A, and then the force of B on A will be an opposing force. Okay, so always for the gears that is driving motion, the contact force between the two gears will be an opposing force. However, for the driven gear, the contact force will be a driving force. Because look here, you need a motor to operate your driving gear. Okay, so you need to put a couple, and due to the interaction between B and A, we have seen that the force of B on A is opposite to F of A on B is downward. So let us use another color for F of B on A. So this is F of B on A, okay? And then this force, the force of B on A, will have an effect of opposition to rotation, because its projection on the tangent line is doing a couple into the counterclockwise direction. However, your gear A is rotating clockwise. So the interactive force between the gears will be an opposing motion of the driving gear, but it will be driving the motion of the driven gear. Okay, because for the driven gear, the only force contributing to its rotation is the force that is transmitted from A to B. However, for when we say a driving gear, this means that we are putting an external couple on it to rotate it. Okay, so we'll see in detail after how forces will be transmitted and how we can calculate, if you want, the corresponding motion of each gear. Now, concerning pressure angles, we have several standards for pressure angles. Not any angle in your mind is present in reality. This is why for gears, we always have to go to tables to see what are the standard sizes present. We have several pressure angles, but the main one used for most common application is 20 degrees. Here we have 3 sizes available in general. We have the gear pressure angle 14.5 degrees, but this is only recommended for replacement of other 14.5 gears. So sometimes in some applications we need them. So just we use this to replace other gears of pressure angle 14.5. But when we have any general application and want to design gears to be used, the most used angle is 20 degrees. Now, a pressure angle of 25 degrees will be used without concern for interference. Now we'll define in a while what is interference and how we can avoid it. So one of the possibility to avoid interference is to increase the pressure angle. But as we said before, increasing the pressure angle is not very recommended because it will be less efficient in force transmission. And we need to transmit forces between our gears in order to ensure, if you want, appropriate power transmission and rotation. So this is why 25 degrees is only convenient for high speed and low power applications, because whenever you have a very high speed, you want to avoid interference, because we'll see that interference can lead to wear of your gears. Okay, and it's not desired in operation, especially if we have very high speeds. However, whenever you have a low power application, you can allow for a larger pressure angles because the transmitted forces will be low. Okay. Now, so going back to 2 gears in mesh, okay, in order to have a perfect match between our gears and to have a smooth operation, we need to ensure the following conditions. So whenever we select a pair of meshing gears, they should satisfy the following conditions: same circular pitch, same module, same diametral pitch, and same pressure angle. And we have already defined these different parameters before. So whenever we have 2 gears in mesh, we should ensure that these parameters are equal to each other. Now, the shape profile of the teeth of a gear must be such that the common normal at the point of contact between 2 teeth always passes through a fixed point of the line of centers of the gears. We already mentioned this. Okay, so whenever you have contact between gears, at least one of the contact points. So we have seen that we might have more than one point into contact at a certain instant, but at least one of the contact points should lie on the line joining centers. Okay. And then we'll see that the location of this point is always fixed on this line, And this is why, and the design of the involute is done in a certain way to always have this contact point lying in the same location on the line of centers, which will define what we call the pitch circles, okay, for each of our gears. And the pitch radius is then determined for each of our gears, and it constitutes, if you want, like as we said before, it constitutes the circles along which we so we can simulate or we can compare then these gears to two rolling cylinders having a radius equal to the pitch radius of each of the gears. Okay, so we'll have at this level rolling without slipping between the two pitch circles, which can be analyzed as two rolling cylinders on each other with no slipping. This is a figure showing in detail what we are talking about. So you have at a certain instant, you have possibility of contact between different teeth. So here, for example, at this instant, you have 3 contact points. So this is 1, this is 2, this is 3. However, always, one of the contact points will be lying on your line of centers, okay? And then this point is always at the same distance from each of centers. This will allow us, as we said before, to define the radius of the pitch circle. So it's like we have 2 circles rolling on each other, 2 cylinders rolling with smooth surface, rolling on each other. By smooth, I mean not smooth, I mean without the presence of teeth. Okay, but of course we should have a friction between them to ensure force transmission. Okay, so it's like having 2 rolling cylinders on each other and without slipping, characterized by a radius for each of the cylinder equal to the pitch radius. Okay, now from here also, from here, we can define another parameter, which is called the base radius. What do we mean by the base radius? We already have seen that we can define a pressure angle. And the pressure angle will constitute the angle between the tangent line to the pitch circle, which is called pitch line, and the normal line to contact between the teeth at the point lying on the line of centers. So this line is the contact line. And then you can see that we can define here. So this line, the contact line will be common, as you can see. It will pass by the different points of contact, and it will do an angle alpha with the tangent line to the pitch circle, which is called the pressure angle. So also we said that we can define the pressure angle alpha between the line joining centers and the line normal to the tangent line. So here, if you draw from this point, if you draw from the center of your gear, a line that is perpendicular to the tangent line, so it's parallel to the normal line of contact here. So this is, it is parallel to the line of contact between, so it's tangent to the involute, okay? You can characterize a new dimension called the base radius. And then you define a circle called the base circle, okay? And you will see that in this case, this dimension can be calculated according to the value of the pressure angle alpha and the pitch radius. Because in this right triangle, this is my pitch radius. This is my pitch radius, and this is my pressure angle. So the base radius is calculated as pitch radius times cosine alpha. So RB, or base radius, is equal to cosine alpha times pitch radius. Okay, you should be familiar with these formulas because we'll use them when we do problems on gears. Okay, don't worry, there is a lot of formulas. We'll give you formula sheets to help you in the exam, but just you should understand these relations and know how to apply them. So here we are summarizing the parameters we have already defined. So we just defined now the base circle. Okay, so here you have the relation between radii of base and pitch circle will be also the same for diameters. So you have the diameter of the base circle is d of the pitch circle times cosine phi. We have defined, if you remember, the circular pitch. We said that the circular pitch will represent the repeated on the pitch circle, the repeated pattern where you have a space and a certain tooth, and it will be equal to pi d, which is the total circumference of the pitch circle over the number of teeth you have. We also defined the diametral pitch, which is the number of teeth over the value of the pitch diameter. So, and we have seen, if you remember, that the product of these two factors will give us pi. So circular pitch times diametral pitch will give us pi. Okay, now we have defined previously, if you remember, addendum, dedendum, which are characterizing if you take a certain tooth and you have your pitch circle level, you can characterize a circle at the top of your tooth, a circle at the bottom of your tooth, and then from the pitch circle to the top, you call it addendum, and from the bottom circle to, please pay attention, the bottom circle is not the base circle. We call it bottom circle, or we call it sometimes also root circle. يعني هو it will go to the bottom of the tooth. بس هي الفكرة إنه base circle is based on the pressure angle and the value of the circular pitch. And it can be somewhere here. Okay, it depends on the value of the angle phi. And we can, from the design, we can relate the addendum and dedendum dimensions. We can relate them to the diametral pitch. So whenever I give you the diametral pitch, you can characterize the values of addendum and dedendum. And for the face width is also related to the diametral pitch, and it's given by 12 over PD. So these, the dimensions of your tooth, okay, are all related to the diametral pitch. Okay, and these values were determined, these empirical relations were determined from design of involutes. So when we did the design and when we did optimization of this design, we got that such values will be convenient for our applications. Okay, so always you have standard values. You cannot find any value on your mind. So you should use these formulas and you should use tables to see what are the available dimensions. And then you select, depending on your application, which gears to use. This will be the scope of the examples we'll go over. I can tell you, I want to design this system. You should select appropriate gears with standard dimensions to have your application done. Okay. Now, we also define, okay, the center distance. We talked about before the center distance as the distance between axis lines, okay, passing by centers. So you can see here, for example, if you have external gears then the total distance between centers can be calculated as the pitch radius of the first gear plus the pitch radius of the second one. While if you have internal gears, then this distance will be the difference between the pitch radii of your gears. So it's the external pitch radius minus the internal pitch radius. So, and we already defined what is the value of our pitch radius. Okay, so here you do R1 plus R2 for external distance, it's D1 plus D2 over 2. And this value D is related to the number of teeth and the diametral pitch. Okay, so from here you can get what is the center distance for external gears, while for internal gears you just have to do R2 minus R1, and R is related to the number of gears and the diametral pitch of your gear. So in general,
I have a question.
Yeah.
What is the difference between pitch and diametral pitch, like on the figure?
Yes, you have that. The way of defining, if you want, if you go back to, I will show you this on the figure to see the difference. Okay, if we go back when we did the definition of here. Okay, look. So first, when we talk about D, okay, D is the diameter of your pitch circle. So once you determine your pitch circle, we said how you see the contact point between the involutes. When you have teeth contact, you determine the point of contact lying on the line of centers. Okay, so you can determine your circular pitch, your pitch circle. Okay, when you draw your pitch circle, the distance between the contact point and the center line will define your radius. Okay, the radius of your pitch circle. And from here, if you multiply by 2, you can get the diameter of your pitch circle D. Okay, now the circular pitch, which is symbolized by P, will represent the distance. So if you go over the circumference of your pitch circle now, you have a repetitive pattern over it. You have a tooth thickness followed by a space, and this will be repeated over your circle. Okay, so from here we define first what is called the circular pitch P. Okay, and the circular pitch P will illustrate this distance, which is equal to the value of the total circumference, which is pi d, over the number of your teeth on your gear. Okay, now for the diametral pitch, okay, the diametral pitch PD will be related to the number of teeth you have and the diameter of your circular pitch. Okay, and so sometimes to characterize gears, they can give you the value of PD and N, and from here you can calculate D. Okay, so whenever you have tables, if they provide you with these two parameters, which represent whenever they give you the diametral pitch, it's the number of teeth over the diameter of your pitch circle. Okay, so if you have these two parameters, you can write that D is equal to N over PD. Okay, and sometimes also they can give you instead of PD, they can give you P, the circular pitch, and then you can deduce the value of the diametral pitch from the circular pitch. So depending on your inputs, you get the output you want. So it's enough to give you two parameters to get the others. So if I give you P, you start by saying I can determine PD by saying that it's equal to pi over P, and then to get my D value, I use that it's N over PD. Or you go directly to your previous slide and you say that the relation between the circular pitch and if you want the number of T's and D is that the circular pitch P is equal to pi D over N. Okay, so it depends on the tables you are using. What are the parameters you have? You decide on how to formulas to use, which formulas to use to get the other parameters. Here they are considering that you know the diametral pitch and you know the number of gears, and from here you can deduce the value of your pitch diameters. Okay, is it clear?
Yes, doctor, thank you.
Okay, welcome. So this is why here they related the distance between centers to your diametral pitch and number of T's parameters. Now we'll see in general. So here, if you want, you have a summary of all formulas we discussed already. Okay. Now we have also another parameter that is a little bit more complex, which is called the contact ratio. Okay, this parameter represents the average number of T's in contact at any instant. So during the operation, you might have variation of the number of T's in contact. Not at each instant you will have the same number of contact points. This is why we define the average number of T's in contact at a certain instant, and it's a little bit complex formula. Okay, if you are interested in the derivation, it's derived in the book in details, but what I want you to know is just the meaning of this number, and we can calculate it according to the following formula. It's equal to the ratio of the length of contact path Z over the base pitch parameter. Okay, so for this reason, we have to calculate these two numbers. For the length of contact path, it is given by the following formula. Okay, and it's depending on the pitch radius, the pressure angle. Okay, and we have also the base pitch. The base pitch we have already defined, if you want, what is the diameter of the base circle. So all you have to do to get the base pitch is to do pi times dB, which is the diameter of the base circle, over the number of T's. Okay, and this will allow you to calculate PB, and this number is common. So we said already, to have two gears in contact, we have several conditions. They should have same value for pitch for the base pitch. They should have same base pitch value. They should have same. So here, if you go back 1 second, so we can add to these conditions here.
دكتور شو هن ال N1 وال N2؟
N1 وال N2 هن number of T's. Okay, so already you have we have set وتشوف big N هي number of T's for gear 1, for gear 2. Okay, so as you can see here already حطينا several conditions for meshing gears. Same circular pitch. Okay, and same value of P, same value of module M, same diametral pitch, same pressure angle, وكمان هلا زدنا another condition اللي هي same base diameter يعني same base pitch. Okay, so here same diametral base pitch. Which is PB. Okay, so all of these conditions should be satisfied in order to have a pair of meshing gears. Okay, and PB, the way of calculating PB is similar to the way of calculating PD. but just here we replace d by dB. Okay, so you have that PB is equal to pi, instead of doing pi d over n, which is the value of P, the diametral pitch, بنزيد عليها d cosine phi بتصير the base pitch. Okay, and the recommended values for this contact ratio is between 1.4 and 1.5. يعني, in general, we do the design anyway to have a contact ratio in the following range. Now, larger values of this contact ratio will have smoother load transfer. لأنه كل ما زادوا الcontact point, كل ما the transfer is easier, okay, and it will be in a smoother way. أحسن ما يكون في contact through a lower number of points.
دكتور الزنا هي same base pitch.
Yes, same base pitch. Okay, PB. Okay, now look, what I will do, I will finish the material and then we'll do examples, a lot of examples to practice on this. Okay, so for the examples, I will leave them to next session. We do examples on all formulas we have seen together. Okay, now what is interference? Okay, we have talked already that interference is not desired, and if the contact, what is by definition interference? So if the contact portions of tooth profiles of meshing gears are not involute, then the gears do not execute conjugate action. That is, the output gear will not have constant angular velocity. This is called interference. So whenever, okay, you have a lack in the conjugate action, this means that you will not be able to ensure a constant angular velocity of your gears, and interference will take place. Now, how can interference take place? If you have gears with too few teeth, then this will, if you want, lead sometimes, you know, if I lose contact between teeth, or if I have one gear will dig into the base of the other, this will cause interference, okay, and this will lead to non-uniform operation of gears. So interference can take place whenever you have gears with too few teeth, or when you have small gear mates with a much larger gear. So it's not recommended to have a match between very small compared to very large gear, because this will lead to interference, and we'll see together how we can avoid interference. We have a table of values, if you want, that will give you what are the conditions to not have interference between gears. Okay, so this is, for example, an interference table. In a table, you can read what condition will not will avoid interference. Okay, so for example, here you have different pressure angles. For different values of your pressure angles, you can read for a certain number of pinion teeth, what is the maximum number of teeth to avoid interference. And here this means to avoid interference. Okay, for example, you can see that if you have a pinion teeth with a number of lower than 23, if you use this pressure angle, you cannot avoid interference. You will always have interference. This is why we say it's not recommended for a pressure angle of 14.5 degrees to have a pinion with a number of teeth lower than 23. So if you want to do a design and you have to use this pressure angle, you start with a number of pinion teeth larger than 23 to ensure that you can avoid the interference process. Now, here, for each number of teeth, you can read the corresponding maximum number of gear teeth in order to avoid interference. If you exceed this number, then you will have interference. So you always try to limit yourself to conditions without interference.